Good morning, good afternoon, and good evening. It is very honor of me to have an opportunity to present an introduction of MP5 Essential Video Coding Standard here, My High Video 2020. Before starting the presentation, I would like to introduce myself briefly. I'm Choi from Samsung Electronics, and I'm a senior engineer and a technical lead position in multimedia standard in Samsung Electronics. I have participated in video coding standards for more than 10 years, and now I'm a leader editor of MPEG-5 Part 1 Essential Video Coding and a chair of a other group of Essential Video Coding. From now on, I would like to introduce MPEG-5 Essential Video Coding Standard. Rationale is as follows. It is well known that video data traffic is relatively huge. According to Cisco report, it is estimated that by 2022, 82% of the global internet traffic will come from video streaming and downloads. This trend has been enhanced after the COVID-19 pandemic. According to recent news, video usage increased up to 4 times more. Due to the increased video traffic, YouTube and Netflix decided to cut the video streaming quality with a lower bitrate. As you know, when reducing the bitrate, the visual quality have to decrease significantly, as shown in the figures from left to right. Historically, a new project of video coding standard was started to provide a better coding efficiency to overcome the limited bandwidth. The two codecs were produced in this year. One is from MPEG ITT, known as BBC, and the other is from MPEG only, known as EBC. MPEG-5 EBC has been developed by MPEG with the following two goals. The first goal is to provide a good coding efficiency, and the second goal is to provide business requirements from the beginning of the project. The second requirement is relatively different from the other codec. The targeting use case includes the offline encoding for streaming, live OTT streaming, and broadcasting services. With such the requirements and targeting applications, the project started in January 2019 using the base framework responded by Samsung, Huawei, Qualcomm, and NVIDIA. The first working draft was released at January 2019. CD was released in January 2019. DIS was in October 2019. FDIS was April 2020. Finally, ISPEC was published in October 2020. Currently, the ISPEC is being available in IS website. The MPEG-5 EBC defines two important profiles, baseline profile and main profile. The baseline profile contains only technologies that are older than 20 years or otherwise freely available for the use in the standard. The main profile includes a small number of tools additionally on top of a baseline profile, each of which can be either disabled or switched to the corresponding baseline tools on the individual basis. Additionally, for still image coding, main still picture and the baseline still picture profiles are defined, which employ the same coding tools as in the corresponding video profiles. This figure shows the block diagram of EBC tools. The green color shows the tools in baseline profile, and the blue color shows the tools in main profile. The individual main profile tool can be switched up as I mentioned earlier, And in this case, the functionality is fallback to the baseline profile tools. This table shows tool flags, which indicates the used tools during the generation of bitstreams. This information is added in the SPS header and sent to decoder. So decoder knows which tools was used for the generation of bitstreams. When turning off all the tools in the main profile, in this case, baseline profile is used for the generation of bitstreams. This table shows summary of tools in EBC codec. Although I want to let you know all detailed information of individual tool, as you know, time is limited. So I briefly introduce tools used in baseline profile and main profile. Baseline supports a quad tree-based coding structure from 64 by 64 to the 4 by 4 blocks. Intra-prediction is the technology to exploit spatial correlation between neighboring pixels by supporting 5 directional prediction modes. Inter-prediction is being used with the bidirectional block-based motion compensation that is conventionally used. The coding of the motion vectors is based on using motion vectors of neighboring blocks as candidates. Transform is using DCT as a code transform for blocks, which is equal to the coding block size. It means that from 64 by 64 to the 4 by 4 are the basis for the transform. After transform, the scalar quantization is applied to the transformed coefficient. The range of the quantization parameter is from 0 to 51, and scaling factor corresponding to each QP is defined by the lookup table. Regarding in-loop filtering, loop filtering based on the H.263 NXJ was exploited to increase objective and subjective image quality for baseline profile. Entropy coding for baseline profile, the binary arithmetic coding scheme in JPEG NXD is applied as the entropy coding engine, and simple run level symbols are binarized after scanning with the zigzag pattern. So from now I would like to introduce main profile tools. The main profile supports of a flexible block partitioning structure, which is based on the binary and ternary trace mixture scheme with a split unique coding order known as XUCO, in order to support efficient and flexible representation of video contents with various resolutions. So to exploit the spatial correlation efficiently based on the flexible coding structure, a total of 33 interpolation modes for Luma components and 5 modes for the chroma component are applied. For interprediction, several tools are introduced in main profile. Firstly, a basic skip mode and the merge mode based on the motion vector competition scheme is supported. On top of merge scheme mode, history-based motion vector prediction, known as HMVP method, is supported, which can be applied to both merge candidate list and the advanced motion vector prediction AMVP candidate list as well. Decoder sign motion vector refinement DMVR method operates with the two motion vectors of the by prediction are further refined by the bilateral temporal matching process. Adaptive motion vector resolution AMVR is supported in main profile to handle multiple motion vectors resolutions. An affine motion mode is supported in based on a main profile as well, which has 4 parameter mode and 6 parameter mode to apply complex motions in interblock. And merge mode with the motion vector difference known as MMVD is being used in main profile, which provides a new motion vector expression with a simplified signaling, including prediction direction, starting point, motion magnitude, and motion direction. Entropy coding for main profile is same to that in baseline profile, except for the use of context modeling with the initialization process. In order to support HDR functionality, DRA is added in the main profile. From now, I would like to share the coding performance ABC objectively as well as subjectively. Firstly, this table shows the objective coding performance ABC baseline profile compared to ABC slash H.264. This testing condition is using CTC, which is defined by MPEG ABC group. The result shows 38% coding gain in 4K and 25% coding gain in 2K compared to ABC, respectively. Encoding time of EBC baseline profile shows about half of ABC, and decoding time of EBC baseline profile shows similar to that of ABC. This table shows the objective coding performance of EBC main profile compared to HEBC. The testing condition is, as I mentioned, defined by the EBC group in MPEG. The result shows 30% coding gain in 4K and 23% coding gain in 2K compared to HEBC respectively. EBC main encoding time shows 4 or 5 times of that of HEBC, and decoding time shows 1.5 times of that of HEBC. In order to check the visual coding performance of EBC verification test has been prepared in MPEG. I would like to share a preliminary testing result. For this preliminary SDR testing result, 4Ks and 2K sequences were used. Similar to objective test, ABC H.264 was used for anchor level EBC baseline profile, and HEBC was used for anchor level the main profile. These tables show the preliminary subjective coding performance of EBC baseline profile, which is compared to ABC. In order to calculate the bitrate saving, the average bitrate saving of EBC profile compared to ABC was computed from the MOS BD rate calculation. These results show 50% coding gain in 4K and 34% coding gain in 2K compared to ABC respectively. So roughly we can say that EBC baseline profile is twice better than ABC in RA condition. This table shows the preliminary subjective coding performance of EBC main profile compared to HEBC. In those tables, you can see that 50% coding gain in 4K and 40% coding gain in 2K compared to HEBC can be achievable. Similarly, from the preliminary SDR result, we can roughly say that the EBC codec achieves the same subjective quality as anchors while requiring approximately half a piece of anchors. In order to check the visual coding performance for the HDR sequences, 6 HDR sequences were used for comparison between HEBC and EBC main profile. This table shows that 36 coding gain in 4K and 35% coding gain in 2K compared to HEVC can be achievable. In order to check the visual quality, I prepared these figures. This figure shows visual quality comparison at the same bitrate. In the figure, you can see some artifacts in the left picture, which is encoded with HEVC. But a clean image can be checked in the right picture, which is encoded with EBC main profile. So we can simply say that at the same bitrate, EBC shows better visual quality. This figure shows visual quality comparison at the half bitrate of an anchor for AK sequence. The left image was used with the 60 megabps using HEVC codec, but the right image was encoded with 30 megabps using EBC main profile codec. As you can see, the image, the visual quality is similar to each other, even though EBC uses half bitrate of HEVC. Conclusion. The main goal of EBC standard is provide significantly improved compression capability over existing video coding standards with timely publication of terms. The EBC is able to deliver the same visual quality as references while only requiring about a half a bitrate used by previous standard. The Amplify V standard is expected to be a great video codec for emerging delivery protocols networks such as 5G, enabling the delivery of high-quality video services to an ever-growing audience by providing improved coding performance. Let's see what will happen in the EBC activity in near future. Thank you for your attention.